Welcome to a lesson on the parallelogram theorems. The figure at the bottom is the parallelogram I constructed using GeoGebra on the last lesson. So we're going to assume that's parallelogram ABDC, so that segment AC is parallel, pardon the screen shift, segment AC is parallel to segment BD, and then segment AB is parallel to segment CD. So we're going to make that assumption. Let's look at some of the theorems. Number one, the opposite sides are congruent. So we're going to say that AC is congruent to BD and AB is congruent to CD in length. Number two, if a quadrilateral is a parallelogram, then the opposite angles are also congruent. So angle A is going to match angle D, and I'll put one mark on each of those. And then angle C is going to be congruent to angle B. So there's congruence there. Third theorem says parallelograms, consecutive angles are supplementary. And that's probably fairly easy to see, since the total angle sum of a quadrilateral is 360 degrees. Don't forget that. All right. And you can probably make the assumption that A and C would add up to 180, but you never want to assume in geometry. But you can just think about extending these lines, the parallel lines idea, that the angle A would correspond to the exterior angle there using the transversal idea. So we're going to have that be true, that any consecutive angles are supplementary. And what that means is that A and C would add up to 180. Also, A and B would add up to 180, any two angles next to each other. The last theorem says the diagonals bisect each other. Okay, so if you draw a diagonal from A to D and you draw a diagonal from C to B, no, they don't cross at a perpendicular, but they bisect one another. And that means that these little segments are the same there. Okay, and this little segment here is the same as this little segment here. So we have all these theorems coming into play. Now, if you wonder about the proof of this, how do we know that it's true? The proof is stem from the idea that since these are parallel, we can draw. I did a little screen shift there. We can draw one triangle going one diagonal going from A to D, develop these two triangles, and we can prove that those triangles are congruent. And we can do that using angle side angle. Once we know that, then we can prove all of the parts are congruent. Let's look at some specific examples, and we have several here to get through. So this, first, assume that all of these pictures are parallelograms. So what we would be able to do here is be able to figure out the value of angle B just by knowing that B plus the adjacent angle, 127, is adding up to 180. So on my calculator, I'm going to subtract 180 minus 127 to get 53 degrees there. Then you would also know that this opposite angle is 127, and then by the same logic, you would know that A is also 53 degrees because it's a linear pair with the interior angle. Let's look at a second. In this diagram, it's also a parallelogram. That's the assumption. We have these diagonals drawn in. Remember, the diagonals bisect one another. So if this diagonal is 14, that half of the diagonal, then E is also 14. That's the distance of this matching this. And this D would be 10. Now, the other thing I need to notice right away is that that diagram is not to scale, okay? So just ignore that. Here is another diagram. If you assume this is a parallelogram, you can use the theorem that opposite sides are congruent, right? That 8Q is congruent to 7Q plus 3. You could set up an equation there. And get to the idea that Q would be 3. Once you know what Q is 3, you can plug it in and find that the value of each of these sides is 24 by plugging in 3. Likewise, you can say that these two opposite sides are congruent, or that 30 is equivalent to 4P minus 2. You would know that 4P then is equal to 32, and you can conclude that the value of P must be 8. All right, once you know P is 8, you can verify that by plugging it in here and seeing that it would be true. You already knew that those sides are both length 30. So if the question asks for the values of P and Q, that's how we would do it. If it asks for the side lengths, we would have that as well. All of those can be used in these theorems.